Calling all educators, students, and space enthusiasts. The 2025 Small Sat Education Conference is where the future of space begins. Join us at the Kennedy Space Center for hands-on workshops, expert speakers, and industry networking, all focused on bringing small sat innovation into the classroom. Explore CubeSats, high-altitude balloon missions, and hands-on STEM workshops designed to launch the next generation of space explorers. Don't miss this chance to connect, learn, and innovate. Visit smallsateducation.org to register today. You can find a link in the show notes. Let's go to Space Blue Sky Learning, episode 149, on high reliability. Today, we meet with Daniel Tatum. He's an electronics engineer specializing in high reliability applications. He provides design consulting services for small startups to get advanced electronics from concept to production quickly. Outside of work, he is a motorsports enthusiast who spends his weekends motorcycling, four-wheeling, boating, and enjoying anything with an engine. Lately, he's even taken up racing remote control NASCARs on Wednesday nights for a little midweek adrenaline. We trust this will be a highly reliable interview that will rev your intellectual engines as well. Welcome, Daniel Tatum. We so appreciate you giving us some of your time today. Reintroduce yourself to the audience. I know I kind of did that little bio, but tell us about you, how you see you.
Well, I'm an electronics engineer, do quite a bit in the way of electronics. So it's my lab. I've put a good bit of time and consideration into it. As a profession, it's kind of what I do, make a lot of high reliability radio parts and front ends for space and aircraft, mostly, some ground vehicles as well. On the swing of hobbies, I do some remote control cars, a lot of NASCAR, bashers, four-wheel drive trucks that launch off ramps, and pretty much anything RC. If it works from over there, from over here, then there you go. We'll work it.
Got it. Well, I'm not sure all of our listeners, and I know for me personally, that are familiar with what that means to be high reliability as far as engineering is concerned. Can you give us a little bit of background?
Well, what does that mean? That means that it needs to kind of operate in a predictable fashion. It needs predictable behavior over a wide, generally temperature and mechanical vibration range. I've never had a part fall off a board and make electronics. Be careful with heavy parts. I generally speaking try to avoid things that need to stake down if I can. But really, it's temperature. I want to say is the one that's the most common gotcha, as you'll find that a lot of components, their behavior varies over temperature, and you need to kind of pick them carefully if you want to have it last long term over that wide operating temperature. So, common CubeSat spec would be like minus 60 to, minus 20 to about plus 65.
Right.
Every 90 minutes. Right. There's your temperature cycle.
So for our
it's a hard life.
Yeah, for our listeners, you think about your TV set full of electronics, but it doesn't move, right? It's stationary. So it is a very narrow temperature range that it's happy with, room temperature, and it does not move. On the other hand, maybe you could speak a little bit about vibrations, because I know you will build your electronics to withstand vibration loads. Maybe the most common failure points that you see with things that vibrate or have wild temperature swings, and just share along that line. That would be interesting.
I have had parts that I had trouble with in the lab. Got my rework equipment behind me, right? So if something breaks, I'll take a hack at it and fix it. If it turns into a difficult amount part, it's like, oh, okay, guys, we need to think of another way to do this. This is not going to happen. But I can think back, just as an example, to a time we were going to lunch, and I was testing something. It's something that I had recently got the hardware back in. It's an attitude thing, actually. Where it's probably why I don't have problems with mechanical. So I take this nice high sensitivity RF board, and I tossed it, I don't know, about 6 or 8 feet back onto my bench, onto some bubble wrap, which I thought was a fine toss. And then somebody brought up the fact that was roughly a $10,000 satellite part that I just rolled onto the bench because I wanted to save 5 seconds in getting a burger. which I reminded them at the end of the day, we're going to integrate this in a satellite and put it up in the nose of a rocket. I hope it can survive a 8 to 10 foot flight across the lab. Which was that it brought up a great lunchtime conversation. It delved on into other things. It's like that's kind of a point. We're going to put it in a rocket. I hope
Right,
parts
right,
don't fall off there. It's like we are going to put it in a vibe shock controlled environment, but the reality of it is I mean, don't spam the test. It needs to not fall apart.
right. So I had the privilege of going to Auburn and visiting a research center called the Center for Advanced Electronics in Extreme Environments. They called it CAVE, which sounds like some of the work you do. But let me ask this. You use the phrase RF board. How about describing for young people or educators who aren't engineers, what does it take to build a radio from scratch? Or in its simplest terms, when you build a radio, tell us a little bit about that in a way for a general audience.
To build a radio from scratch, you're going to need some kind of transceiver, first and foremost, right? That's just your core radio unit. There's a whole breadth of levels of integration to that. You could go with something this package like a Doodle Labs radio, or maybe some of the Milcom radios are actually also happen to be video data companies. So in other words, they do like your Super Bowl live video, 8K. Those are also your UAV companies, incidentally. Right. They have sister companies. So you could get any level of complexity you want there as far as, let's say, the transceiver is concerned.
Let me pause, Dan. You said transceiver, but our audience needs to know that is both a receiver and a transmitter, correct?
And a transmitter. It's talk and receive. I assume that you want to do both, right? Not just listen. Now you could. A receiver is a lot easier. The complexity of building a receiver is easier than a transmitter. So I would say start there. If you were to, really think, hey, I want to get into this, then get yourself a receiver. It's a lot cheaper hardware. And by the time you get your antenna and your low noise amplifier figured out, the inbound signal, you'll have developed some experience that you'll need to work into building a transmitter, which gets into having higher power levels, and you have to be more cautious. You'll start breaking hardware and costing money quickly. So, but really, the things you need: transceiver, the thing to talk and receive, and an antenna are the basics. And how you kind of go about that, you can keep getting more and more complicated. Tracking systems, or phased arrays, or pick your poison. A phased array is a electronically steered antenna.
So do you work for a company currently? I'm sure you have in the past, or do they consult with you? Like, does someone hire you out?
I'm a consultant, so I basically do stuff that, for the most part, I hate to use this term, but it kind of does serve it well. I deal with underserved customers. They need like 10 of something for some prototype, and maybe the design files to it. And it's like, okay, well, I can get you 10 working prototypes that you can use for your demo whenever that is. So there's a schedule involved, and we can work out terms on how exactly we want to go about like IP development, delivery, the logistics of it. Sometimes they really do want the design files. That's clearly priced differently than maybe somebody who's wants more of a partnership, if you will, where they want you to continue to provide them with said widget. So, which is let's say becoming more of a business venture for me. On a side note, it's like, products company. That's something I should put more thought into.
Well, yeah, I would think that even as, people who are dabbling in kind of like building these parts, or like even like yourself.
You can make example hardware that people can buy, and you can put it in their hand. That goes a long way. It really does. If you can go online and get something that's similar to what you want, it's not lost on me because I've done this for a long time. I go to the same websites for the same companies for the same components, and every single time the exact thing that I'm looking for, if it's Milcom or Satcom, it's not on the website. So I hit the contact us, and you wait. I don't wait a week. I will tell vendors out there, since some of them may be listening. It's like, by the way, people get back to me in 2 or 3 days, and those are the ones I go with.
Right.
So I'm that kind of company too. So right. I have things to do, guys. This program schedule is like 2-3 months long, and they want hardware, right?
Yeah.
Right.
You got to move quickly, right? I mean, there's no slack time on that. So
You have to be agile when you're small, right? So
you do, and it's not that hard, frankly. It isn't. Be amazed what you can fish out of DigiQ with some extra, a little bit of know-how and some custom parts here and there.
So
So,
let me ask this, Daniel. When you were training, when you were getting your education at Virginia Tech and Georgia Tech, did you ever say,
mhm.
I'm going to have my own company one day? Was that in the plan originally, or did you sort of
I,
evolve into
I
that?
had I had to dive back on that one for a little bit. So that is a great question. I sat and thought to myself, I was like, Dan, there was a time in life that you got out of trade school. We're gonna open up a CV shop and be like make the best CV radios, and you decided, and you're looking at that, looking at college, and like, wow, that corporate job sure does pay good. And there's a lot of terms that come tied into that. I don't know if it's for me. It's kind of where I'm at there. So the last place I worked was a smaller company, a much smaller company. It was like 28 people. I think they're similar in size now. I think they've grown. They grow and shrink a little, but it gave me a lot of perspective on. Basically, they gave me visibility, a lot of visibility into how the company was run, funded, how much contract bids were, how they went about that. I was tied in system level quite well. Like the beginning of the company, for example, they had bid some contracts for doing some CubeSat radios, which I mean, where do you get experienced people doing this? Haha, short list, right? So they hired me in to do that. Stick me in front of Doug Liddell, the what was it, CEO of In Space Missions, this little 20-person startup in Britain, and talked with him for a minute. Great guy. Got on with the program management and ended up doing 4 missions with them, 4 different, software-defined radio, power amplifier, receiver front ends for CubeSats. Basically the interface with the CubeSat power bus and are basically designed to be indestructible and easy to integrate.
Right,
Right? I mean, just give them something simple. Geez, come on, guys.
right.
And that went really, really well. It really did, and it was just like, wow, that's all it really takes. All it takes there. And so they ultimately got bought by like BAE just to continue it, which is kind of the goal, right? And why did we
And
pick this customer? We thought that was going to happen. That marries
right.
BAE to the startup I work for.
Yeah,
Wow,
so
there's just
for our listeners, BAE is like a big prime, right? They're
yeah,
a huge prime company. I believe they are UK based, but they do a
they
lot of
are.
business in the US. They're a big
Yep.
defense contractor. So
Well, and you say like,
That's
oh, this is easy, we can just give them, but it's easy for you, right? You're providing a service to them that is maybe time consuming that they don't want to
it's so
necessarily spend the time
confusing.
on,
Yeah.
right? So it makes
Uh,
sense. It's like definitely
yeah.
a good win for both.
So I
it
have
is. It gets
I
done.
yeah, I have a question that's a little more general and it's a little
Hmm.
more teach the audience kind of class. So what we know with CubeSats or small satellites is they have limited power for their transmitter, right?
Hmm.
They have limited area for their antennas, right? But on the ground,
Hmm.
you can have very large receivers and you can
Hmm.
have a lot more power. How do
Hmm.
you make those two worlds come together when you build a CubeSat radio?
So you bring up a critical piece of all that success with the UK guys. Is very early on, I was put in touch with the ground station equipment folks who had a pretty good idea as to what they would need for a system like the close. The power budget indeed is a very real problem. Not only do you have limited power available to run the amplifiers, but when you burn that power, you heat the chassis. So that's something to keep in mind. Expelling heat from cubes, that's a difficult prospect. You're generally sending it. I don't know about modern ones, but sound some heat pipe, usually dumping it in the solar arrays has been an approach because it's radiation. There's no atmosphere, right? Convection, conduction, no. I mean, it just kind of saturates the chassis at some temperature, and that's where you are. So, generally speaking, there is a great asymmetry there. The ground station equipment is equipped with a higher gain directional antenna and often a tracking system. There are a number of websites out there that provide telemetry data for a lot of the satellites in orbit, or not most of them.
Well, like Kevin, I'm thinking of some of the CubeSats that you've done. That was one of the biggest issues you had with your first one, right? Was the tracking or like because they are
Well,
so small, you had to
yeah,
really
well,
work with
that's
it.
different. She's referring to where is my CubeSat versus,
Uh,
how to talk to it. Now, we circumvented that by using an omnidirectional antenna that talked up to
I
Globalstar
see.
or Iridium because there's a lot
Yeah.
of them and we don't have to find our ground state. We don't have to point at any particular target. We just
Uh-huh.
sort of blast it up everywhere and somebody will hear us. But she's referring
Mm.
to the Space Force had a hard time finding us because they deployed too many CubeSats, too quickly, and the Space Force had a hard, or the Air Force had a hard time differentiating which blip on the radar was which CubeSat.
So I actually don't have a lot of visibility into that operational aspect of it. Um, I'm kind of more on the component side of it, so I basically learned enough from those folks. Don't get me wrong, I do get to see some of it, and for what it's worth, as a I guess components developer, if you will. Because bear in mind they are in the UK, right? It was a little bit of an unusual relationship
Right.
because
Yeah, yeah.
I was basically here on the webcam like you see, doing I have some other cameras as well, but we work back in the lab and fully COVID era kind of project, right? So
So you
uh,
had to figure out how to build the most powerful radio you could with the least amount of heat.
so basically we came up with a power spec that was achievable. A lot of the antennas are bigger than what's basically okay. So think about the antennas. They're stowed versus deployed antenna, right? So the bulk of what I did was UHF VHF band, so it's easier to get through the atmosphere anyway. Get through on lower power, right? So and the other side of the coin is you can use like those little mylar copper and mylar antennas, kind of like a tape measure basically. It just kind of unfurls. What they end up doing is taking a piece of resistor wire and burning like a little filament.
Oh no, we've
So
done the fishing line.
yeah,
That's easy to
yeah,
teach
yeah,
the
yeah.
kids.
So they burn the fishing line and deploys the antenna. And that seems to be kind of the way that kind of goes about. Most of the elegance as far as the system, I would say, is pretty much in the ground station equipment,
Hmm.
which is a current customer, actually, frankly, is I've been getting some ground station equipment. I've done a little bit of GSE, and I guess I don't know if it's appropriate for this, but there's a couple companies I could kind of
Yeah,
direct you
I'm
to.
sorry, Daniel. You can't flip out GSE for our lay
Ground
on.
station equipment.
Oh, ground
Even I
station
got that.
equipment.
No, even
Yeah,
I got that because
yeah.
it was
Well, it's
very close.
contextual.
No, it was right.
It was
Yeah.
Exactly.
contextual,
Even I knew. Even I knew.
but this isn't a military briefing, so we have to limit
Yeah,
our use of
ground station
acronyms.
equipment, GSC, ground station equipment. Yeah, right. So, yeah, so the big, huge dish on the ground that's full of equipment. So, those really vary too. I've gotten to see, like, I've seen little rooftop units out, working at a startup in California that were amazingly high performance. I mean, this is something that we'd go up on the roof and literally like, tool on it. It's not a tall tower. It's like our height because the guy who built it's about my height. It's great.
Well,
So, and I've been out. Go ahead.
you finish first, and then I'm going to
And
correct
I've been
you.
out to like PAX NAS, right? And at PAX Patuxent River Naval Air Station, which if I had like a opinion like of what I saw, it's like this is a Cold War era early warning system is exactly what this is. And got to see some things there. It's like wow, this is quite the sight you have here. It was very impressive, very very impressive. We had a moment of fear of heights being real. That one, I got
Well,
to see
I'm
it.
imagining that you kind of get an order. Like, so let's kind of set this up. You get an order from a company, somebody who needs to have something tested there. So you're there by yourself in your lab, which is behind you, right?
Uh,
Kind of tinkering away. How describe for us like what that might look like for you? Is it like different projects obviously take longer, but like it's just you there, right? And you're just
yeah.
communicating.
Yep, it's just me.
So what are
So,
those
what
challenges
is this?
about, you know,
There are numerous. I would say, well, I mean, it's not all smooth sailing. It's a lot of time, a lot of hours. I got some hardware in Friday that, all right, we'll just go over that program schedule. That one's pretty straightforward. Customer came to me, they didn't quite know what they wanted. I talked to them momentarily, and I'm like, I've done these before, and frankly, as far as like the process of their thinking and where they're going to end up with this, I've done that before too. So, more than just the hardware, your system, what you're trying to figure out, what you're going to talk about, what you're not going to talk about, what you're going to present to me, what you're not going to present to me. Yeah, I've been through this rigmarole on a number of projects, sure. So, I mean, everybody says that, right? So, um, I give them a proposal. It's basically a spreadsheet for this little amplifier. It does these things for you. I think it meets criteria what you need. You should like simmer on that for a little bit. They came back. They're like, we need a little more. I'm like, this is going to end up with a spec compliance issue. So I doubled the performance and hit a lot of stuff in it, and then represented it like 2 months later, right? Like, here you go. When they came back to me eventually on this thing they wanted, I'm like, so here's this other thing. I'm like, well, it meets these criteria, but last time you said you'd have a hard time doing that. Like, yeah, I redesigned it. It'll be okay. So they had to simmer on that for a little bit. Sure. They got back to me and they're like, hey, can we get a little more out of it yet? I'm like, okay, here's the band of performance that it offers for you, since they kind of figured out what you're doing. And so I got to go ahead a few days later after that one, and made the hardware, sent it out, basically pulled all the triggers for everything that had been kind of backed up. There's a lot of small companies and custom parts involved. So that's why I say a lot of this is DigiKey, but there are some real genuine high performance custom made parts that have real lead times involved and things, right? So
yeah, DigiKey audience is a supplier of electronic
correct.
components.
A lot of components.
Think of it as the Costco
distributor.
Yeah, like a Costco. Yeah.
Well,
right.
so I'm imagining then, so it sounds like your job is to resolve problems. All right,
Well,
like the multiple
yeah.
problems that seem to come up,
but it has a real hard, like tangible deliverable, right?
Yeah.
Work and
your
make the customer
experience,
happy.
right? Your experience helped you deal with the customer's scope creep, right?
Yes, that's exactly right.
Yeah, you were able to, because of your
creep.
experience.
That's exactly what that is.
I'm very familiar with yes.
They cut it out after that when I kind of showed my cards after that, because there was a little bit of a believability issue, like a customer trust. We were building trust at this point in the relationship.
No, but I'm thinking you had to be familiar with those specs and tell them. I mean, they're a company ordering something
you
that
tell
might not.
them So when you have a Steve Jobs moment, you can't just shove it down their throat. You have to let them have that epiphany. So you have to wait.
Yes. Yeah.
Yes.
It
was a game of patience.
Yeah, I have two areas that we could probably spend days on, but we only have a couple of minutes. So I'm
sure.
I'm going to hit you up with the two areas that you're welcome to speak on, one or both. One, do you ever are you invested much in dealing with like the FCC and how they allocate bandwidths for users? And my second question is, do you do anything with encryption or decryption, or is that an area that's involved in what you do?
Kind of no to both. I read about FCC stuff. Do I speculate on how they allocate the band or get into the politics of it? No. It does strike me as a political conversation, and we'll stay away from that. But the as far as dealing with the masks and the existing requirements and meeting those requirements, that I do. And I don't like to be, as I kind of mentioned with the whole spec creep thing. Don't just meet the requirements. If you can exceed that and get yourself some production headroom, that'll earn you a customer for life, and that's the best kind. And I think my old boss had said, "Hey, man, never, don't ponder too much on new customers. Make sure you hang on to the customers you have. Right? Those are your best customers, or your current customers, always." So.
Well, as we kind of come to a close here, we sometimes have like advice for kids who might want to be this, but I'm wondering if in general you could maybe kind of as a closing, tell us the kind of person that you think would be ideal. Like what is maybe a student who's in college now thinking about, well, maybe this is an area I could specialize in or look into. What are the qualifications or the characteristics that you think would be a person who might go into something like this field?
I'm a big believer in anybody can do it. If you want, you just try it. Quite frankly, there's a lot of great open source tools out there. Don't get into the politics and the people talking smack about whatever. If you want to get into it, just go download a copy of KiCad and read some stuff online and try.
KiCad, is that
KiCad?
K-I-K-A-I?
KICAD, KiCad.
Okay.
That is frankly an excellent hobbyists. I mean, it's bordering a professional software for doing like the electronic PCBs, and there's no limits to it. It is open source, so you
Uh,
don't have any gotchas.
Boards.
yeah,
None.
Daniel,
Yeah.
we have an 11-year-old in Norway that made the first board for our fourth satellite, and he used
Yeah.
KiCad.
Well, that was
So
Eric.
Nice.
you,
Yeah,
when you say that,
it's there. It's
he
there.
is, I mean, he looks like a flipping genius when he's on the Zoom flipping through his images and he's like, yeah, I built
Yeah.
it. And here's my layers. And
Yeah.
I agree with you. And isn't that free? Isn't that like a
It
free
is.
Of
It's
course.
open source. It is
Yeah.
completely free. No gotchas. So I read a write up, speaking of the trash talking, that I think spelled it right. And it was Altium versus KiCad. Altium's professional tool is very expensive, right? It is. KiCad is like a stick shift Toyota. You can go out there, it'll get you work. You know it will. It will. It will every time. You have to drive it. You have to push clutch in.
So it's easy. So it sounds like it would be something that maybe you need to mention with the Wolfpack kids, like these
We
trainings
already
that you're
use it.
doing. I know that
Yeah.
he does,
Oh.
but he needs to do a workshop to train other kids and how to do that.
Actually, what you don't know is Daniel's on our short list for giving a workshop at the conference
But
this
Eric's
year.
the one you said who
I
did it. The
see.
one
Yes.
it's not Daniel. So it's
No,
Eric.
that's Daniel.
Oh,
Yeah,
I understand.
I see.
Yeah,
Sorry, we have a student named Daniel too.
yeah,
So
we're
That's all good. Yeah,
we're
happens.
I know that we were speaking to you about potentially running a workshop at our conference
you
this
should
year.
totally do that. I will sit
Yeah.
in and like try to absorb it.
Yeah.
That the way to do that, frankly, is to stick something up on GitHub as an example where you can download it and get started and give a library out. Starter projects are the way to do it, frankly.
Yeah.
So, a little documentation. There's a good simulation tool out there too that's also free. I'll mention that. It's new name, USIMMICS, USIMICS.
You spell that
It
one more time.
used to be USIMMICS. They used to call it Qux Studio, another open source project with a little more drama in its history, if you will. It's a splinter, but they're supporting it, so good to
So I
see it.
think that the general parting kind of advice here is to find out what's available for free in these areas.
Yeah, absolutely.
and
There's a
tinker with
lot
it,
of great
right?
tools out there.
Learn
Uh-huh.
from that. All right. Well, we really
A
appreciate
lot
this,
of it
Daniel.
was
Hope
done
to
for
see
free,
you
yeah.
at that conference, like I said. But beyond
Thanks.
that, we look forward to talking with you again.
Thanks. Yeah, it was great being here. Thanks for having me.
And thank you, Daniel. We look forward to seeing you soon.